Okay, in this session we are going to learn about the entity relationship model. Okay, entity relationship model. We talked about data models, right? Where we realized that a data model is a set of conceptual tools that helps me to define the schema. It helps me to specify the schema in such a way that a layman can understand it. So entity relationship is a type of a data model. Okay. So let's see how does an entity relationship model maps a real world into the database. Let's first understand what an entity is. An entity is any real world object or thing, any real world thing that can be distinguished from other things. Okay, so there should be some mechanism through which you can identify that thing that can be distinguished. So let's see some examples of an entity. A person, okay, say Alex, that's an entity. A cat, say Tom, that's an entity. Okay, a car, say Toyota Prius, that's an entity. So anything can be an entity if it can be distinguished. Okay, an entity has an entity type. An entity type is basically a specification of that entity. It determines what are the characteristics of that entity. Okay. The other thing that we have to understand here is an entity has different characteristics, right? And these characteristics are called the attributes of the entity. Attributes are characteristics. Okay. So let's say we're talking about a person entity. So person would have some characteristics, right? He would have a name. He would have a date of birth. He would have an address. He would probably have a phone number. He would probably have a profession. Okay, so these are the characteristics of person. In entity relationship model we call them the attributes. So let's see how we represent an entity and its attributes on an entity relationship model. An entity is represented as an oval. Okay. Oops, my bad. Entity is represented by a rectangle, not an oval. Okay. So this is the representation of an entity and we write the name of the entity inside it. So if I have to represent persons, the set of all the persons, I'll write it like this in an entity relationship diagram. Okay. Let's introduce a new term here. We talked about what entity type is, right? Did we do that? Yeah, we talked about entity has an entity type, which is the specification of that entity. Let's talk about entity set. Entity set is the collection of all entities having same entity type, right? Same entity type. So that would probably mean, if we are talking about the entity type person, then the entity set of person would be the set of all the persons that have a name, a date of birth, an address, a phone number, and a profession. Okay? You can think of it like this. Entity type is a class, and entity set is all the objects that have been created of this class. Okay, so we were talking about the representation of entity. So this is the representation of entity. Now let's look at how do we represent attributes. An attribute is represented via oval. Okay, so when I say name is an attribute, I can represent it like this. When I say phone number is an attribute, I can represent it like this. So we talked about that an entity has attributes. So how do we relate these attributes to the entity? That can be done by connecting the attribute to the entity. So we represent this entity like this. We have a name, we have a phone number, we have an address, we have a profession, and what else do we have? We have a date of birth. So in this way I can represent the attributes of an entity. Okay, so let's revise the representations just for a moment. Entity type is represented by a rectangle, and attribute is represented by an oval. Okay, now let's understand what is a domain of an attribute. Domain of attribute. Domain basically tells me what are the set of permitted values that an attribute can have. So I'll just write it down. It is the set of permitted values. So when I say a phone number, I would define its domain as, say I'm talking about mobile numbers which are 10 digits, then the domain of phone number is the set of 10-digit numbers. Domain works basically as a constraint on the value. It's a constraint on the value of the attribute. Okay, when I say the domain is 10-digit number, then I cannot have a phone number which is 1, 2, 3, 4, 5, 6, right? Because this is a 6-digit number. So it's not allowed. So we've covered domain of an attribute. Now we'll look at types of attributes. First type is a simple attribute. Or we'll rather look at in this way. It's a simple or, not or, it's a simple versus a composite attribute, okay? An attribute is either composite or simple, okay? When an attribute in itself can be divided into other attributes, okay? Like we have an address. So the address can have a flat number, it can have a location, it can have a city, it can have a state, right? So such attributes which themselves can be bifurcated into other attributes, other simpler attributes, are called as composite attributes. So address is a composite attribute and a flat number is a simple attribute. A location is a simple attribute. A city is a simple attribute. We cannot go any further, right? A city cannot have a sub-city and a sub-sub-city, right? A city is a city. A sub-city would be a location that in itself is a simple attribute. Okay? Had we looked at it in this way, if we didn't had this, we probably had just a city, and city would be bifurcated into a location. So in that case, city would be a composite attribute. It would have a city, location and area, something like that. So we've taken a look at what is a simple attribute and what is a composite attribute. Now we'll see how a composite attribute is represented. Okay, so it's simple. It's represented like this. Address will be the attribute which is composite, and it is composed of, we'll write it like this. It is composed of a flat number, of a location, of a city and a state. Okay, and this is the attribute of person. Right? This way we represent a composite attribute. Composite attribute is something that can be further divided into a simple attribute or a set of simple attributes. Next we come to a single valued attribute versus a multi-valued attribute. So when I use versus, what I mean is an attribute can only be either single valued or multi-valued. It cannot be both, right? It can be either composite or simple. It cannot be both. So let's suppose our attribute phone number. A person can have any number of phone numbers, right? It can have 2 mobile numbers, it can have 0 mobile number, it can have a mobile number and a landline number. There are so many different possibilities. So in that case we say that phone number is multi-valued. It has many values. It can be more than 0 or more than 1. In both the cases it is called as multivalued. It may happen that it doesn't have any value at all. There may be some person who lives on the street who doesn't even have a landline number, let alone a mobile number, right? So we're talking about greater than equal to 0. Let's see how we represent a multivalued attribute. A multi-valued attribute is represented as a double oval. That's the way to do it. This is a multivalued attribute. Person has 0 or more phone numbers. Okay? Next we'll see what is a derived attribute. Derived attribute. Derived versus stored attribute. Okay, let's suppose we have a date of birth attribute. From this attribute we can at any time find out the age of the person, right? So from current time, if we subtract current date, if we subtract the date of birth, we would get the age. There is a set mathematical formula to do that, right? So in such cases we say age is a derived attribute. And date of birth is a stored attribute. Just keep in mind, date of birth is a stored as well as a simple, as well as a single valued attribute, right? Single valued. So how do we represent a derived attribute? It is via a dotted oval. So we have the person and we have his age or her age, if you will. That's the representation of a derived attribute. Now let's take a look at the special value that every attribute can have. We call this special value as a null value. Okay, null value indicates that either the value of that attribute is unknown, or it is missing, or it is just not applicable. Okay, just keep in mind that null is in the domain of every attribute. So what this statement basically means is every attribute can have a null value. For example, say we know President Obama, right? America's president. He obviously has a name. His name is Barack Obama. He has an address, that would be White House, right? He has a phone number. Obviously we know he has a phone number, but it is unknown, right? So we'll keep it as null. Or for that matter, we'll take another example. Let's say we have a person named Joe who lives on the street. Okay, so Joe has a name, but when it comes to address, He lives on the street. He may be living on one street one day, probably some other street on another day. So he doesn't have an address in proper sense of the term. His address is not applicable, or in other words, in our database it would be null. Okay, so that is about null values. Now we'll introduce a new concept of relationship. Relationship basically models the interaction between one or more entities. Okay, so let's see how do we explain this with an example. Let's suppose we have a person and we have a pet. So the relationship between the person and the pet is that a person owns a pet, right? By owning a pet, this person is interacting with a particular pet. So these type of interactions we abstract into relationships. So our entity relationship model is basically comprising of entities which you've already seen what they are, and the interaction between these entities called as relationship. It is an association between entities. Let's take an example. Let's take this example only. Let's say we have Jimmy, we have Rob, we have Janie, we have Sean. Okay, these are persons, and we have some pets. Okay, let's say we have a Tom, which is a Persian cat. Say we have Mac, which is a German Shepherd. Say we have a Cece, which is a goldfish. And say we have Bruno, which is a boxer. Boxer is a dog. Okay. So let's keep it like this. These are the persons and these are the pets. So I say Jimmy owns Cece, Cheney owns Tom, and Rob owns Bruno. Okay. So we'll have a relationship between Jimmy and Cece, Jenny and Tom, and Rob and Bruno. Just understand here, Sean doesn't own anything, okay? Doesn't own any pet. And Mac is not owned by anyone. Okay? So just like we had entity set, we have a relationship set. It is the set of all relationships which have a common relationship type. In this case, that relationship type is person owning a pet. So I'll just tell you how do we represent relationships. Relationship is represented by a diamond, like we've done it here. Owns is a relationship and it's represented by a diamond. Next, what we'll see is a relationship instance. Relationship instance is one of values in the relationship set. Okay, it is like, let's look here. Jimmy owning CC is a relationship instance. Okay, I'll write it down. Jimmy owning CC. That's an instance of the relationship set which says a person owns a pet. When an entity participates in a relationship, it basically means that it is a part of some relationship instance. Okay, so I say that Jimmy participates in the owns relationship, okay, while Sean does not participate in the owns relationship, because there is no relationship instance where we have Sean owning some pet. The next terminology that we are going to introduce now is role of the entity. Role of the entity basically decides what type of interaction the entity is having. Okay, so in our example, it is the person owns pet. So the role of person in our case is that of owner. He is interacting as an owner. And the pet is interacting as something that is owned by. Okay, so pet is owned by the owner, and the owner owns a pet. Okay, so every entity has a role. Role is important whenever we have a relationship which is interaction of two more entities of the same entity type. We call such relationships as recursive relationship. Recursive relationship. Okay? Say we have a set like person, okay, and we have a relationship marries, or rather marriage. Marriage is a relationship. Okay, so in this kind of a relationship, two entities are involved, but the point to realize here is both the entities are of same entity type. Okay, so now role comes into play. One person is playing the role of a husband, and the other person is playing the role of a wife, right? So role is important in recursive relationship. It's most important in recursive relationships, I would rather say. Okay. Now we'll take a look at descriptive attributes. Descriptive attributes are the attributes of the relationship. Okay. There may be some attributes which are not actually characterizing the entity but are characterizing the relationship. Let's revisit our example. Person owns a pet. In this case, we can have an attribute which says or determines the date when this pet was brought home. Okay. I would keep it as brought home date. Brought home date is different from the date of birth of this pet. Okay, there could be a pet which was born in a kennel. There could be, like we had Mac, the German Shepherd. If he was born in a kennel, then obviously he was not brought home on the day he was born. He was brought home probably when he was 2 months old. But this person is more interested in when this pet or Mac was brought home. So this information is represented as an attribute of the relationship set. Okay? So we say where did our example go? Okay, we don't have Mac being owned by anyone. Okay, so I would take this Rob and Bruno example. So we can say that Rob brought home Bruno on 15 December 97. Okay, so this is the information which is represented by a descriptive attribute. It is an attribute of the relationship and not of the entity.